Hey future engineers, how are you all? Welcome to the channel where learning is fun, where the formula meets tricks and stress meets strategy. Okay, so I hope you have watched the first part of this session. Okay, so what we're doing right now, which session sir? The session is Sankalp KCET 2026 batch we are doing right now, right? Okay, so in that session number 1 has been conducted. So we have done the bridge course and we have done the part 1 of the chapter relation and functions. Okay, so today we're gonna do part 2 of this particular chapter. So of course we'll see the types of functions today. You'll get to know from the chapter planner why we are here today, because our goal is to get one of the desired, the best colleges in the CET, okay, and secure a good rank and get that desired college. So today's video again will help you get few steps closer to that particular college of your choice. Let's start the chapter planner. Over here we have part 2. 1 was types of relations, as we have already done. Part 2 today is going to be types of functions. Part 3 I'll be coming here with CET, KCET PYQs, and part 4 will be JEE Mains PYQs. Same goes over here in Sankalp structure. If you see in Sankalp batch we have one segment as concept sessions. The segment number 2 is KCET PYQs and segment number 3 is JEE Mains PYQs. So I hope this is all clear. Okay, now let's look at why we are doing all of this. What's the purpose of sir coming here, watching your sessions, learning from you and solving the questions? Because we have a goal, okay, and that reflects from the story that we have to tell for so many students, not only here, okay. These are the results from YouTube that we have taught in the previous year batch, which is 2025 batch for CET. We had such a good results: 171 rank, 443 rank, 693 rank, 752, 934, 1197, 2043, 2072, 2427, 3430, 4139, 4381, 5216, 5534. Starting from Prajwal, Kiran, Diksha, Samiksha, Sachin, Harshit, Chinmay, Tanmay, Mohammed Sahil, Kirtana S, Athar, Anshuman, Akash and Gagan. All of these and many more. Actually, we couldn't have taken all the names over here in this slide. That's why I have missed some names. But if you have watched our session, the result session, you know we had so many toppers. Okay, so much great results we had from our PUC and CET. Okay, now your goal, your task is to study from us. Okay, be consistent in your work, follow our statement, what we are telling you to do, solve the questions from, do that. If you do that completely and honestly, I'm telling you, be assured that you will be among the rankers in the next year's 2026 CET. Okay, and your name, your picture will be displayed over here. That's your goal, your name, your picture in the among the rankers of CET 2026. Okay, trust me, you can do it. Just believe in yourself and put it in the comment section that yes sir, we can do it. I'll be a ranker in 2026, and come back and let me know that as well. Okay, so let's start the session now. Your time is very important, I understand that. I know I have taken some single minute of your time. Okay, 1 or 2 minutes. Let's start the session right away. What we have, so in the session outline today, what we have today, first we're going to learn about types of functions. So in the types of function we have to learn of course the bijections is the end goal. So first we'll learn one function, on two functions. Okay, how to identify that, different approach to identify that. Okay, there's some tricks also involved. We'll teach you that as well in the session itself. Okay, there can be a longer method, basically the algebraic method. We can also use some graphical approach to solve the questions faster. Okay, so I'll teach you all of that in the session today itself. Okay, that is your first section of this particular session, types of function. Next we'll move on to question practice, of course. So I've taken some questions over here. I'm going to solve all of it in detail for all of you. I hope this works. So let's start the session right now. Okay, so we have in types of function today, what is it sir? We're going to see one function, on two function, because that's where the question are coming in this particular section of PU2 or 12 section. Okay, yes, in PU1 from this chapter you have questions on domain and range. Okay, for various different type of functions you have domain and range questions. Okay, but from the PU2 section or the grade 12 section you have question from the 1 on 2 functions. Okay, so we'll see the definition of these functions quickly, and we'll see the different approach how to solve or identify a function as 1 or on 2. Okay, again there can be more than one approach. There can be approach of derivatives. Okay, there can be approach of simply using the algebraic method as well. So we'll see all of that. So again, I've taken today only minimum number of questions. I think I've taken some 5-6 problems today in this session. There will be a practice session for questions itself. In that we'll see variety of questions and more number of questions. Works. Let's start now. So if you see types of functions, 1 injective function, a function f a to b is called 1 if distinct element of a have distinct images in b. Now what this statement means, what this statement means, if you draw a mapping from two sets, let's say this is set A and this is my set B. set A and set B. If you want to draw the mapping from set A to set B, and I have, let's say, element over here as 1, 2, 3. 1, 2, 3, and over here I have 6, 7, and let's say 5. 6, 7, and 5. And if I'm mapping 1, I can map 1 to 6, 2 to 7, and 3 to 5. Means for this function which is defined from A to B, okay, I have unique images of all the elements of set A. What is the meaning of images? These 6, 7, 5 are called as images of elements of set A. Images of elements of set A. Okay, again 1, 2, 3 is the element of set A. Okay, the set B is called as, what do you know that? Set B is, we know this already, is called as codomain, and set A is called as simply domain. This is domain. So for every element in the set A or the domain, there must exist unique images and distinct images in the set B. Please check here, distinct images in set B. I hope this is clear now. For example, for any x1 which is not equals to x2, what it means is, it means for those two elements of the code of the domain, x1 not equals to x2, the function value f of x1 will also be not equal to f of x2. Can we justify it over here? Please check. If 1 is not equal to 2, value of the function at 1 is nothing but 6, value of the function at 2 is nothing but 7. Are they equal? Of course not. Okay, so even though 1 and 2 are not equal, at the same time 6 and 7 will also be not equal. Makes sense to all of you? Yeah. Okay, this is 1 injective, or also called as injective function. Now another way to, so how you solve this question? For this given, any particular question given to you, you can have algebraic approach. This is your method 1. Algebraic approach will be there, method 1. Now method 2 will be the graphical method. The graphical method. In this, what you do? You simply draw the graph. Of course. Okay, let's say I'm drawing the graph of sin x function. Okay, sin x function. All right, and if you after drawing the graph of sin x function, you try to draw a straight line parallel to the function, parallel to the x-axis. When you get what? You get total of, please check in this case, 4 intersections. Actually, it will be n number of intersections, because this sin x graphs extends on both sides till negative infinity to minus, from minus infinity to plus infinity. So you'll have infinite number of intersections available. But for 1 function, you should have always unique, or basically one intersection. So to identify any given function as 1 function using the graphical approach, simply draw the graph of the given function and draw a straight line parallel to x-axis. If you get one intersection, you can say the given function is 1. If not, you can simply say that the function is not 1 or many one. Okay, not 1 means simply many one. I hope this makes sense to you. There's another approach, I'll tell you that later. Right now, okay, I can write it over here only, I have some space. Method number 3 is the approach or use of derivative. We'll see this method in the coming slides. Okay, when I take a question on this, I've taken one question. So in that, while solving that particular question, I'll show you what is the approach to identify one function using the derivative method. Okay, let's begin now. I hope this is clear. Again, I'll not talk too much about the derivative method, because if somebody who has not studied derivative, right, it's PU2 part, then it's no use of using it right away. Okay, but I'll tell you brief of it. If you know derivative very well, you can use this condition and make use of it. I'll give you the quickly results. Okay, so many one function, just opposite to what you learnt in 1, it is going to be many one. Means whichever function is not 1, basically going to be what, sir? Not 1 is called as many one. So if I have to draw the mapping, same way between two sets A and B, okay, so you'll have, check here, for more than one elements in this, you'll have same image. Okay, for more than one elements in the domain, you have same image. You won't have distinct images. So let's say I call this to be element is 1, element is 2. I have, let's say the element over here is A. So whether you take element as 1 or element as 2, you get the image as always A. The image is not distinct in nature. That's called many one, many to one. Please check. Okay, so there exist at least two distinct element in A. In the, what does A mean, sir? It means domain. So at least two elements will be there in the domain for which there will be same image. There will be same, yeah, they have given here, image in B. Okay, you can have other cases like this. Let's say I like this, I'll have 3 to B, 4 to D, not a problem. Okay, so yes sir, 3B represents one part, but since at least even one is there, no, I have one pair of elements in set A such that their images is the same in set B, in the codomain set. Okay, if that is there, we can call the function to be not one or simply many one. Okay, I hope this makes sense to you. Okay, so I think this is very clear, right? Okay, so yeah, okay, I'll talk about this over here only. The method 3 that we were talking in the previous slide, M3 was derivative approach, okay, or method. Okay, so what you're going to do in this, simply check for f dash of x. For any given function you have y equals to fx, right? This is a function given to you. Okay, so you find f dash of x, you find the first derivative of the given function. Once you find that, check the nature, whether it is more than 0 or less than 0. So I'll see either option A or option B, not both. Understand this very clearly, either A or B, not both. Okay, either A or B, not both, not both. I don't want the function to be both, so at some part increasing, at some part decreasing. I don't want that. I want the function to be of only one trend, which is either increasing or decreasing in nature. Derivative should be either positive or negative, not both. For example, if I take the positive part, the graph will be like this. Let's say the graph will be like this. This is a graph of what, dear? E power x. Yes or no? If you differentiate e power x, what is the answer going to be? E power x only, right? And e power x has no negative value in it. Exponential function does not have any negative value. Okay, if I talk about, let's say, decreasing function, I can go over here. Okay, I can go like this. Let's say this y equal to minus x. Y equal to minus x is a decreasing function. Okay, so you can see here the graph is having the trend of decreasing, means as I move across the x-axis, y value keeps dropping. If I move towards right of the x-axis, no, y value keeps dropping. That's called your basically decreasing function. So don't worry about that right now. So if you have, basically check here, if f dash of x is more than 0 or f dash of x is less than 0, if you draw any straight line, no dear, if you draw, don't worry about decreasing, increasing right now, because that part will come in, that part will be taught to you in calculus section. But understand this, if you have increasing, if you have the positive value, means graph will be like this somewhat. Okay, so please check, you will have a again unique intersection. So whether it is this kind or this kind, if you draw a straight line, you always have unique intersection. You'll have unique intersection. I hope you get it. This represents negative slope, right? Please check. If you draw a straight line over here, this is an angle theta, let's say, which is obtuse angle, so negative slope. I hope this is okay. So for negative slope, this is f dash of x means slope only. You learn that in calculus again. Understand this clearly. This is going to be utilized if you don't want to use right now. If you know derivatives, it's okay. You can use this method. Otherwise, I'll ask you to not use this method directly. Okay, because not required right now. Once you learn the calculus, of course you can use that in the examination point of view. So I hope this part is clear. M3, method number 3, using derivative. If it is positive, means only positive or only negative. Understand this very clearly. Don't worry about anything else. Don't worry about the graphs and all. I can erase this. Let's erase this graphical part. I don't want to confuse you. So may erase this part. Just check whether the derivative is positive or negative. Derivative is positive means it will be what you call 1-1 function. It will be 1-1. Negative means again 1-1. Understand, it's only this case, not both, sir. Only positive or only negative. If it is both, then let's say I have a graph which has both plus and minus sign. For example, I can take this graph. Check here, this graph. Here increasing, here decreasing. Okay, here the derivative is positive acute angle, here it is negative obtuse angle. Okay, so if you draw a straight line, now you get two intersection which is not 1-1, which is not 1-1. I hope you get it. If you check the graph of y equal to mod x, right, you get two parts, two intersection you get. That's why not 1-1. Okay, you can see here for the one of the part it is positive, other part it is negative. You can't have the combination of plus and minus. Derivative has to be either everywhere positive or everywhere negative. If it is either everywhere positive, 1 1, either everywhere negative, 1 1. Okay, but don't look for the mix of it. Okay, I hope this makes sense to you now. Only this much you remember, that is good enough for us to solve any question in with the approach of method number 3 if it comes our way. Works? Okay. Now next is some method to check whether a function f a to b is 1 1 or many 1. I already taught you all of that. Please check. First method is consider any two elements. So two elements, you're going to take x1 and x2 from the domain, okay, and find the function value at that, f of x1, f of x2. If x1 and x2 is equal, if x1 equals to x2, then you also get f of x1 equals to f of x2, okay. Secondly, if f x1 not equal to x2 you have, then f of x1 will also be not equals to f of x2. This is going to be the case of 1 1. If you have x1 x2 equal, your function value also be equal. If you have x1 x2 not equal, your function value will be again not equal. If you have this case 1 1, any other case will be many 1. Okay, great. Great. Okay, then we have if any straight line parallel to x-axis. I already taught you this method, the graphical method. Okay, parallel to x-axis you're going to take, and if you have one intersection, if you're taking straight line, you get one intersection, 1 1. Take a modulus function like this. Two intersection, you're going to call this as many 1. Many 1. Works, simple enough. Moving on. Next is the onto function. So 1 1 part is done, 1 1 many 1 is done. Next is onto and into. Let's look at it. Onto is also called a surjective function. 1 1 was called as injective function. I hope you remember that. Onto is called a surjective function. Okay. A function is f a to b is called as onto function if it has the codomain. You know what is codomain, right? The codomain is equal to the range of the given function. How do you find range? Of course, we can find range, right? We have learned that in PU1. It's okay, when I start the PU1 chapters, I'll teach that part to you again. Okay, and in the questions, I'll teach you that as well, of course. So understand it over here. So whenever you have range of the function equal to what is b, sir? Codomain of the function. You call the given function to be onto function or surjective function. Okay, into, sir, just reverse. If you have to check about the onto into, you'll have at least one element in B which has no pre-image. What's the meaning of pre-image, sir? Image means, for image part, if you remember, this is set A and this is set B, right? So let's say set A is having 1 2 3 and set B is having ABC. So A is the image of set element 1 in the set A. Oh, sorry, yeah, there are too many A's. Okay, I'll change that. Let's not confuse you. Okay, X, Y and Z. So X is the, if you can repeat after me, X is the image of the element 1 in the set A. Okay, X is the image and 1 is the pre-image. I'm going to repeat myself. X is the image of 1 and 1 is the pre-image of X. Same way, Y is the image of 2, Y is the image of 2 and 2 is the pre-image of Y. Same way, Z is the image of 3 and 3 is the pre-image of Z. Okay, so there will exist at least one element in B which will have no pre-images, for example, okay, yes, the function is many 1, not a problem, but Z is an element in the codomain which has no pre-image. Something will be left out. When you have that, that is called as the case of into function, or basically not onto. What is into means? Not onto. Into means not onto. Okay, whenever you have something left out in the codomain, think about it. Now, what is the range over here, dear? Range will be, if I have to write the range set, I'll write here x and y, no? X comma y. And what is the codomain? Your codomain is nothing but x, y and z. X, y and z is the codomain. Are they equal? No. If equal means onto, not equal means into. Clear? Okay. So you have, whenever you have something left out in the codomain, you call the function to be into. If you have to draw for onto function mapping, for onto function, if you draw the mapping, please check the mapping will look like this. Okay, so I have here 1 2 3. Let's have here again x y. Okay, z is there. All right, 1 second. 1 2 3 4 am I right? Let's say here like this. Okay, check this out. So every element in the codomain B has some pre-image in the domain A. For x it is 1, for y it is 2, for z it is 3. So 4 is left out. You don't have to worry about that. When you are thinking of onto into function, no, don't worry about set A, worry about set B. Okay, onto function means that every element in the codomain has to have at least has to have a pre-image in the domain. For z pre-image is 3, for y pre-image is 2, and for x pre-image is 1. It means I can check directly from here. My codomain in this case, which is set B, is nothing but, have a look, x y z, and at the same time I have range also. I have range as well. What is the range, sir? X, Y, Z. And aren't they equal, dear? They are actually equal. Range and codomain are equal. It means what? Whenever we say range and codomain equal means what? It means it is onto function. Onto function. I hope this makes sense to you. Simple enough. So I explained to you 1 1, many 1. Onto into, all explained. 1 1 is 1 1, of course we learned it. 1 1 means unique mapping. Onto many 1 means not 1 1. Onto means domain and codomain and range equal. Into means not onto. That is the way to remember it. It will be easier for you. Okay, shall we move on now? I hope this makes sense. Yeah. Now, okay, so something is methods to check whether a function f a to b is onto or into. First thing is find the range of the function. If it is equal, simply onto function. Second method, let a to b consider y. Okay, same thing. Okay, so basically take any value of the element from the codomain, and for that value y, you make x. Find the value of x now. Okay, so basically for any value of y, right, you find the respective value of x. If x, that value coming out belongs to the domain, it is onto. If not, into. Please check. Okay, if x does not belong to A, it will become not onto, hence into. Same thing. Basically you can use direct approach or reverse approach. There's one more approach. Okay, I'll tell you over here. There's one more approach. So right here, method number 3. This is method 1, method 2, method 3. What is method 3, sir? Try to put x tends to infinity. Okay, your function values will also tend to infinity, and it is not or case in the case like in the case of in the 1 1 function. Okay, over here you have and cases. In that we said f dash of x is more than 0 or less than 0. Okay, in this case you have to take and. So x tends to infinity, right? F of x tends to infinity, and x tends to negative infinity. Y should, or fx should also tends to negative infinity, sir. Both should be true. If you have both, you can say function will be what, dear? Onto. Function will be onto. Method 3, I'll repeat again. If you substitute x as, you can't substitute actually. If you try to take x to infinity, your function will also approach to infinity. Also, if you try to take x tends to negative infinity, if you approach the x to negative infinity, your function value will also approach to negative infinity. When that is true, both the cases are true, you call the function to be simply onto function. I have taken a question. Later, I'll show you the application of that as well. Works out. Please check this is clear. Not a problem. Moving on. Right? Yeah. Now bijective function, simple sir, very simple. Combination of both 1 1 and onto. So you learned that already. Combine a function which is having both nature. 1 1 is there, onto is there. Both combination is possible. 1 1 and onto both is possible. That function is called as simply bijective function. This is called as, remember, injective function, and this is called as surjective function. So if you have a function which is both injective and surjective, it's called as simply bijective function. Okay, great. Distance, basically these are definitions only, right? This is a definition of 1 1 function. Distinct elements of A has distinct images in B, and each of element of B is the image of some elements of A. Okay, means none of this is, nothing is left out. No element in B is left out. So mapping will look like this. Please check. You have mapping over here, A like this, B, if I have 1, 2, 3, 4, 5, you'll have here X, Y, Z, phi and theta. 1 is mapped to X, 2 is mapped to Y, 3 mapped to phi, 4 mapped to Z, and 5 mapped to theta. Means you'll have unique mappings, and nothing should be left around. There is nothing left around and unique mapping. This is called as 1, 1 on 2, or simply bijective, dear. Bijective function. Makes sense to all of you? I hope it is. Let's move on. Yes? Okay. Now, yes, over here this concept is simple, but yes, formulas are important from this chapter. Questions can be asked. Okay, you'll see the problems. I've taken some. Number of functions when is defined like this: A is the domain, B is the codomain, and what is represents? This represents the cardinal number of A. So this you check over here. I can write like this: N A M B basically means that, or mod of A basically means what, dear? Cardinal number of set A, which is nothing but how much? In this case, they have given here M. Same thing is there for set B also. What it represents? N represents over here the cardinal number of the set B. Okay. Then the number of functions is given by N to M. Number of functions given by N to M. Okay. Second formula is number of injections. One is given here. No? Sometimes they can ask you number of injections is given by what, dear? NPM. NPM, the permutation wala P, okay? So NPM. The number of onto function is given like this: mass 1 power n minus r, NCR, r power m. R power m, from where to where? R belongs to 1 to n again, okay? And number of bijections, if you have n either less than or equal to m, the number of bijections is given by n factorial. Otherwise, it will not be defined, sir. If you have n less than m, no? Sorry. Yeah, it is more than m, no? They will not be defined, bijections. It has to be equal, then you go like this as n factorial. Works, okay? Let's move on. First question that we have, let's solve the first question. Let R is 1, 3, 4, 2, 2, 4, 2, 3, 3, 1, okay? Where relation on the set A is 1, 2, 3. The relation R is what? Relation R is what? We are asked that to identify relation R as either function, reflexive, not symmetric, transitive. For function, the definition is very simple. Understand this. I hope you learned the function definition in the PU1 only or in the 11th grade. If not, I'll teach you again later. But right now, I'll tell you one statement. What is it? You should have a unique mapping in functions. Okay. Check here. Value 2 is giving me 4 and 2 is giving me 3 as well. So for the same value in the domain 2, I have 2 images. Means not a function. Simply not a function. 2 is linked to 4 and to 3, so not a function. You can't have a function definition like that. Okay. Next, what we have? Reflexive. Of course, not for reflexive. We should have 1, 1, 2, 2, 3, 3, and 4, 4 should be there. Which is not there means remove reflexive also. Symmetric. Okay, transitive or symmetric. We check first. 1, 3, 3, 1 is there. 4, 2, 2, 4 is there, but 2, 3, 3, 2 is not there. We have 3, 2 missing, right? Should have 3, 2 over here. There is 4, 2, 2, 4, but we have 2, 3 as well. There is no 3, 2. It means that not symmetric. Option is simply C. Simply option is C. Why not checking this for this, sir? But there is no need to spend some time in it. You can see clearly it is. It can never be symmetric, right? Then why to spend some time to check this? You can check it out. You want 3, 3, 1, 1, 1 is not there. So not transitive. Please check. I have 1, 3, 3, 1, but 1, 1 is not there. So even transitive is not possible. Please check. Works. Question number 1, option C is correct. Question number 2 now. Left a function defined from all real number to all real number means domain is all real and codomain is also all real. Please check. Domain and codomain is both all real numbers. Okay. Fx is defined like this: x plus mod of x. Critical point is 0, I think. Please check. So redefine this function for x more than equal to 0 and for x less than 0. I get this as x minus x, so simply it becomes 0, and for this I'll have x plus x, simply becomes 2x. Draw the graph of this function. So graph will be, the graph will be 2x means like this. After 0, this is 0, right? After 0, the graph is always 2x, and before 0, it is always 0. Okay, you can see here simply not 1 1, sir, because if you take value of x as -4, okay, take -3, any value you take, -2, whatever you take, every time it is y is 0. So for all different value of x or the elements in the domain, the range is, the value of the mapping is same as 0. It means what, dear? It means not 1 1. What about on 2? Please check. Here range is what? Here range is 0 close to infinity, open. What's the codomain? Codomain is all real. Codomain is all real number. What is the meaning of all real number? From -infinity to +infinity, open, open. This is the meaning of all real number. Are they same? They are not same. It means not onto. From here you can see that not onto. So please check. You can say either not 1 1, not onto, or say many 1 into. Option D is correct. Have a look. Option D is correct. Please check. This is clear. Option D is correct. Works. We can move on. Yeah. Next is third question. Let the function f r to r. Again, the domain is all real. Codomain is also all real. Defined like this: 2x plus sin x. X belongs to real number. Then f is what? Okay. We're gonna use the method of derivative in this. The method number 3. We're gonna use in this case. Have a look. Find f dash of x. If you have known this, it's okay. If not, pay attention over here. Derivative of 2x, no. 2 will remain as it is, and x is a variable. Differentiate with x. You get x as 1, and sin x derivative is what, dear? Is simply cos x. Simply cos x. So my answer will become what? 2 plus cos x is my f dash of x. Now check the nature. Cos x, if you check cos x graph is like this, right? Right? So this band is +1 and this band is -1. So this cos x graph never goes out of -1 to 1 bond, right? This is -1, okay? So cos x can never go more than -1 and 1. It has to be in the limit of domain, you know, right? -1 to her range of the cos x, -1 to 1. If you take that with 2, take the extreme value, you're gonna get t2 -1. How much is that going to be? 0. Okay, sorry, not 0, sir, sorry, 1. 2 -1 will be, what, dear? It will be 1. If you take the positive part, you'll have here 2 plus 1. How much is that? 3. So this f dash of x is basically can be between 1 and 3. So always positive. F dash of x is from where to where, dear? From 1 to 3. Please check. F dash of x can be minimum 1 or maximum 3. So always positive. It means f dash of x is always positive, sir. What happens in that case? It's going to be simply 1 1 function. Simply 1 1 function. Correct now? Simply 1 1 function. Okay. Now check for onto. Check for onto. So okay, we'll use. I want to delete this part and the graphical part. Okay. And we use method number 3 for onto function also. Have a look. So if you take in the fx, 2x plus sin theta is given, no, sin x is given, right? Substitute x as plus infinity. What will happen to this function? So fx will become what, dear? Please check. Twice of infinity will become infinity only, no? And again some value sin x will be between what and what? -1 to 1. If you add -1 to infinity, it remains infinity. If you add +1 to infinity, it remains infinity only, right? So fx tends to infinity. First case. Second case, please check. Okay, in the same function. Okay, 1 second. Yeah, in the same function, same time, put x this time as -infinity. We have to check for both the cases. Both has to be true, right? So x has -infinity. What happens to f of x? Please check. This will become 2 into -infinity. Will become what? -infinity only, right? 2 into -infinity is how much? -infinity only. Okay. If you add plus or minus to this, if you add +1, In infinity you add plus 1, it doesn't change, right? So it will become, it will simply be negative infinity only. So simple, I want to conclude over here. When x tends to plus infinity, fx tends to plus infinity. When x tends to negative infinity, fx tends to negative infinity. I explained to you this is the method number 3 to find onto function. So basically, your given function fx is onto. So what we have? 1 1 onto. 1 1 onto. Okay, I hope this is clear. If not, I'll write it again. Okay, just a second. 1 1 onto option is, option A is correct, right? Please check. Option A is correct. Okay, I hope this is all visible to you. Yeah. Okay, let's move on to the next part. Next is the function f r to r. Again, domain is all real, codomain is all real. Defined like this: x square plus 1 power 39. Okay. Now you will use in here definition approach, the simplest one possible. Find the value of function at minus 1. Answer will become minus 1 square plus 1 power 39. How much is this? Please check. It will turn out to be 2 power 39. Okay. Take here a function value at plus 1. I have 1 square plus 1 power 39. I again get 2 power 39. 2 power 39. Basically, when minus 1 is not equal to 1, are minus 1 and 1 equal? Of course not, sir. Minus 1 and 1 is not equal. What I'm getting? F of minus 1 is equal to f of 1. They are both same, no? 2 power 39, 2 power 39. It means even though the x1, x2 is not equal, remember this definition, x1 is not equal to x2. We had the case of f of x1 not equal to f of x2. But in this case, I'm getting here f of x1 equals to f of x2. It means not 1, 1. This is the case of not 1, 1, or basically many one function. Means for distinct element in the domain, you have the same image in the codomain. Okay, it means not 1, 1 or simply many one. Now for onto, you check what's the range here, sir. Range will be here. The minimum value, possible value for this will be 1, right? Because any value you take for x except for 0, it becomes some number. Whether you take negative, whether you take the small value, negative value, doesn't matter. If you take minus 100, it will become plus 100 square, right? Because we have x square plus 1. So the minimum value for this, inside the bracket, the minimum value for this will be what, dear? 0 plus 1, right? How much is this? 1. So this minimum value of the inside part is only 1. Okay, this bracket can be minimum 1. So what is my answer going to be? 1 power 39. Basically, what is that? 1 to infinity. So your range will become close of 1 to open of infinity. It can go all the way till infinity, right? You can take any value of x, it will keep increasing because the power is 39, and you put x as any value, negative or positive, square will make positive, so it will become, it will keep going to infinity. Okay, so your range is 1 to infinity. And what is the codomain? Your codomain is actually all real. All real, it means what? Minus infinity to plus infinity. Are they equal? Range is not equal to codomain in this particular case. But I can say not onto. So a given function is not 1 1 not onto, means either many one into or the same case. Option C is correct. Please check. Option C is correct. This is clear. Simple enough. Okay, have a look. Option C is clear. Moving on. Next one. Set A has 3 elements and set B has 4 elements. Number of injections, right? Okay, we're going to use this, no? NPM case only. So we have over here 4, 3. So 4 P3, how much is this? 4 factorial divided by 4 minus 3 factorial, right? Becomes 4 factorial divided by 1 factorial. So 4 factorial is the answer. How much is this? 24, right? 24. Option C is correct. Okay, injective function will be given by 4p3. We found it like this as 24. Option C is correct. Next one. You can see the question can come on any of this case. Which of the following is 1 1? I want answer directly option number A. Because this is a bell curve. These are standard curves, right? Bell curve. you have the curve like this. Okay, and sin x is like this. Please check. Excuse me, it's weird one. I'll change it, make it more realistic. 1 second. The sin x curve, if you take any straight line, no, like this, you will have too many intersections. Please check, which is this, not 1 1, right? Not 1 1. Over here also you take the straight line, you get 1 2, you take over here so many, so not possible to take one intersection. So both B and C are wrong. Option A, if you check exponential function, you'll have the function like this. This is your function e power x. Anywhere you draw, you get only one intersection. This is your 1 1 function. Answer is option A. Answer is option A. Please check. I hope you have the clarity. Sin x, bell curve, and so this is e power x square. Okay, clear? All right, this is clear. So these are standard curves. Okay, you have to remember these curves. This is the important one. Let's move on now. So I think this is it for today. So as I said, I have not taken many questions. If you are waiting for the domain and range question, as I told you, those are part of PU1 syllabus. When I start the PU1, I'll do those questions as well. I'll teach you those concepts also in detail. But as of now, we were focused on the PU2 part of the syllabus, which is nothing but 1 1 on 2 function based questions keep coming. So we have seen that today. I hope this session was very helpful to you. Let me know what you feel in the session's comment section. I'll get back to you if there is any query. Again, see you again very soon. Till then, take care. Bye-bye.